Today we are going to see module 4 IEEE 802.11 wireless LAN security. Yes, there are two types of network as we all know. One is wired and the other is wireless. What is wired network? In many organizations, the wired network is an Ethernet LAN. If two or three stations are connected with the help of Ethernet LAN, with an existing security infrastructure that includes an authentication server. With the authentication server, if two or more stations are connected with the Ethernet LAN, then it is wired network. AAA, it is nothing but authentication, authorization, accounting functionality is often provided by the radius. So we said we should have authentication server. So what is the use of authentication server? It is used to provide three things, that is authentication, authorization and accounting. What is authentication? Authentication is checking, and authorization is there are two things. We have to prove ourselves, and authorization is who is going to check, that is authorization. So authentication, we are going to prove that we are the authorized entity, and authorization, who is going to check whether we are the authorized entity, that is authorization. And accounting is, and see, if I'm making call from one station to other station, that should be accountable, right? How much duration this station has communicated with that station. So the accountability is also done in the authentication server. So the example of authentication server is radius, that is remote authentication dial-in user service. This is about wired network. Next comes wireless LANs. There are two principles of wireless LANs. One is ad hoc network and another is infrastructure wireless LAN. Ad hoc network is readily, immediately. If you are going to set up a network, that is called ad hoc network, where stations possibly it can be mobile or it can be static also in ad hoc networks, communicate directly with each other. Infrastructure wireless LAN, some infrastructure will be there which can use the access point. So the stations will be moving, but it will be using the access point, that is infrastructure wireless local area network. So this is actually the example of the diagram in which we are seeing here. It is example of infrastructure wireless LAN. See, the access point is the infrastructure. Okay, it is connected to the wireless stations. So it is infrastructure wireless LAN. Okay. Yes, a station first sends a frame to an how the infrastructure wireless LAN works is like this. A station first sends a frame to an access point. See, if I am coming to the coming nearby the access point, I am the mobile station. I am moving, and I am coming across an access point. What I have to do is a station will send a frame to the access point, and then AP delivers it to the final destination. If I send any data to the access point, then what happens? The access point will take the responsibility to send it to the destination. If I am the station 1, I have some data to communicate with the station 9. So whichever access point is nearby, I have to send it to that. The station 1 should send it to that access point, and the access point of the station 1 will take the responsibility to deliver it to the station 9. It can be, the station 9 can be directly connected to the access point, which is taking the data from the station 1, or it can be connected with the other APs. So the first AP will take care to deliver the data to either the destination directly or to the access point to which the destination is connected. Next comes, the destination may be another wireless station, as I said, or it may be a station on the wired network that AP is connected to. So that will take the responsibility. The AP thus serves as a bridge between the wireless LAN and the existing wired network. So it acts as a bridge. The challenge then is to develop protocols that seamlessly integrate the wireless LAN with the security infrastructure of the wired network. So how we are going to integrate both? That is the challenge here. Yes, a network of wireless stations associated with an AP is referred to as a basic service sets. As we saw in the diagram, if I have one access point and it is surrounded by the stations, wireless station, then it can be called as basic service set. Such a network may be adequate for home or small enterprises. Okay, small companies, small sized companies, it is adequate. The union of the basic service sets comprise an extended service set. So all the basic service, the combination of all the basic service set is nothing but extended service set. Each station and the AP in the ESS is uniquely identified by a MAC address, a 48-bit quantity. So how the station and the access point is identified is with the help of the MAC address. And one more thing they have, that is service set ID, which is 32-bit. Yes. So there are two things how I can attach to an access point. The first first way is it can be done by monitoring the wireless medium for a special kind of frame called a beacon. So see, I am the mobile station, I am passing through some access point. One way is how I can attach to an access point, how I can be a member of basic service set is the first choice is the AP. Every AP will be sending the beacons periodically. The station whichever passes through the access point at that time can get the beacon and it can reply that I want to be the member of your BSS. That is one way possibility. The other way is, if it is not getting the beacon from the access point when it is arriving inside the basic service set or near the access point, then it can give its own, the station can give the request frame to the access point stating that I want to join your access like basic service set. And by taking the request frame, by accepting the request frame, it will give the response. The probe access point will give the response if it wants to add the station to its own service set. Like the beacon, the probe response frame consists of the SSID of AP and also the information about its capabilities, supported data rates, etc. So in the response frame which is sent by the AP to the station, it will give the information such as what its SSID is, and what are the data capabilities it can give, what are the data rates it can provide. These are the things it will services, like what are the services it can provide to the station, that will be given in the information which is sent along with the frame. It is response frame that is sent by the access point to the station. So these are the two ways. Either access point can send the beacon periodically, with which the station can attach to itself to the AP, or if the station is not able to get the beacon frame which is sent periodically by the AP, it can send its own probe request frame for which the AP will respond. A station that wishes to associate it with AP sends it associate request frame. As I said, the same thing is there. So for that, associate response frame will be sent by the access point. The earliest protocol that incorporated security in the Wi-Fi was WEP, Wireless Encryption Protocol. So designed to provide authentication, access control, data integrity and confidentiality. It failed all the three counts. So wireless protocol, Wi-Fi protected access was intended to fix the shortcoming of web. So in order to provide the shortcoming, in order to fix the problems faced by the web, they introduced WPA, that is Wi-Fi protected access, without requiring new wireless network cards. But WPA is not perfect. It is also too susceptible to attacks on its cryptographic algorithm. So they went for the other solution called WPA2, that is Wi-Fi protected access 2. All the deficiencies in the web has been addressed in IEEE 802. Even in this, they found some issues. So they went for the IEEE 802.11i. Okay, what is there in IEEE 802.11? We'll see. It uses 802.1x, a protocol that supports authentication at the link layer. So here we are saying that the authentication is given at the link layer. So what are the three entities involved here is supplicant, authenticator, authentication server. So supplicant is nothing but the wireless stations, and the authenticator is access points, and the authentication server, it can be like as I said, radius server. Okay. Different authentication mechanisms and the message types are defined by extensible authentication protocol. So IEEE 802.11 uses the protocol called EAP, that is extensible authentication protocol. EAP is not really an authentication protocol, it is just a framework. The exchanges are more EAP exchanges are mostly comprised of request and the response. So simply it's a combination of request and response by which they can authenticate. Later response with its first, what happens, what is the first step? For example, one party requests the ID of the and how I can check whether he is the authorized person or not. So first one party will give the request ID of the another party. The later response with its username or email address. EAP also defines messages that may contain challenges and responses. As we said, nonce and its response can be given. The AP broadcasts its security capabilities in the beacon or probe response frames. The station uses the associate request frame to communicate its security capabilities. And 802.11 authentication takes place after the station associate with an IP. After the association of the station with the IP only, this authentication process takes place. What is authentication process? That is challenge and response. That's it. It will ask for some question. If they can answer, then they can prove that it is an authorized entity to communicate. So what the radius is going to do? It is going to do three things, that is authentication, authorization, and the appointing. Yes, the diagram is shown here. That is, first step is identity request is given to the station by the access point. For that, identity response is given, then it is sent to the radius server, radius access request. To access the radius server, a access point is giving the request, then it gives the challenge. So it has to prove by itself that it is authorized access point and the station. So radius is giving the challenge, then the challenge again, access point is again giving the challenge request, authentication request to the station, then it gives response, then which is sent to the radius access request again. Now this is from station. First was from the first radius access request is from the AP access point. So then radius access accepts, then it is success, it is giving success. So like this authentication is done in IEEE 802.11i. Then what about confidentiality and integrity? See, in the web we faced so many issues, it cannot provide confidentiality, integrity, and access control. Why it is so is it is susceptible to the plain text attack, non plain text attack. That is why web is not secure. So they moved on to the protocols like IEEE 802.11i. Why the web was not successful is it uses a short random key stream which is a very small size, which can be reused, which is susceptible to the known plain text. That is why web was not successful. So we went to this IEEE 802.11 I data protection. So in that what happens is we are going to use two protocols, that is TKIP and CCMP. So TKIP, how it is going to work is TKIP is Temporal Key Integrity Protocol. So what was the shortcome in the web data protection is the key stream was very small, which can be reused or which can be regenerated, which will be the cause for the known plain text attack. So in order to avoid that only, we went for this TKIP. So what we have to do, we have to increase the length. That will be the intention here. So TKIP generates a random and different encryption key for each frame sent. There it was same key. So what happens, for every frame different encryption keys were used and generated a random and long uh, key stream. So it employs a process called two-phase key mixing. The inputs to the process are the 128-bit temporal key computed as part of the four-way handshake, the sender's MAC address, and the four most significant bytes of 48 frame sequence counter. The randomizing capability of the key mixing function and the large size of the key, as I said, space virtually guarantee that keystring collision never occurs. It cannot be same at all. Thus, known plain text attacks that could be successfully launched in web have no chance of success with the TKIP. So, if you are going to use TKIP, then there is no chance of known plain text attack. Next comes CCMP. The implementation of 802.11 that uses AES is referred to as WPAT. Its technical name is Counter Mode with CBC MAC Protocol. So how it is going to work? This count is referred to as a packet number. The count is maintained and both the sender and the receiver ends. The packet number is also included in the special CCMP header field in the CCMP frame. So this CCMP is used to check the integrity. Our TKIP was used to check the confidentiality. So how we can check the integrity is with the help of the field called packet number. So when the receiver gets the packet, every packet it will be counting. When the receiver checks receives the packet, it will be counting one by one. The packet number value will be stored, and the packet number value in the header and the packet number value which is stored at the receiver is same, calculated by the receiver is same. Then it will come to the conclusion that integrity or data has not been changed, or it has not been replayed. So this is how the CCMP helps to provide the integrity to us. So with this we are completing our session. Thank you. Bye bye.